Hi, folks. It's Miss Clark, and today we're going to talk about lesson 1.9, which is proving theorems. And this is your first intro into geometric proofs. And the goal for today's lesson, or for this lesson, is to define and use the transitive property of equality and theorem. So the transitive property of equality and theorem, and to prove vertical angles are congruent. Okay, so that's what you're going to be doing with this particular lesson. As we start going into the more complex topics, there will be proofs for every single one of those. So let's talk about some terminology. So some conditional statements are postulates and some are theorems. So as you recall in a previous unit, like the segment addition postulate, a postulate is a statement that is accepted as true without any proof. But a theorem is a statement that can, in fact, be proven. All right, just like the Pythagorean theorem. You can prove the Pythagorean theorem, but the segment addition postulate, although you can prove it, it's just accepted as true without proof. Okay. Now, specifically, the transitive property of equality, okay? It's a specific type of substitution involving three quantities. For example, if we say that A is equal to B and that B is equal to C, then A is also equal to C, right? And I use that example with numbers. So if A is 21 and B is 21, then B, being 21, if it's equal to C, would make C 21. So by the fact that A is equal to B and B is equal to C, then of course A is equal to C. All right, that was supposed to go to C. All right, so an example with angles looks like this. If the measure of angle G is equal to the measure of angle H, and the measure of angle H is equal to the measure of angle J, then the measure of angle G is equal to the measure of angle J. Okay. But how do you prove a conditional statement? Well, you do that by using a two-column proof. All right. So a two-column proof is a logical argument presented with statements and corresponding reasons in order to justify a conclusion. So it requires two columns. And we're going to talk about what that entails. So a two-column proof. So as you can see, column 1 are all the statements you're making, and column 2 are your reasons in defense of those statements. Okay, it's almost like you're a lawyer and you're trying to prove your case. You make a statement, you back it up with a reason. So let's talk about proving the following. So it says in the example, if angle A and angle B are supplementary, and angle A is equal to 6x plus 105, and angle B is equal to 3x minus 20, then x is equal to 5. We're going to use properties of equality and the definition of supplementary to justify that x is equal to 5. The way a proof will be written is a little different. You'll be given a statement or several statements, and you'll be told to prove something. You'll be given a given, and you'll be told to prove something. All right? So when you're writing your two-column proof, the first thing you're writing is the given statement, and the very last thing that you write here is what you're trying to prove, or what you have proven through your statements and reasons. All right. So let's dig in here. All right, so as you can see, I rewrote this given in the first box. So that's my first statement, and its reason that I used to back it up is that that was given to us. Always the first thing you're writing in a proof. The second statement that I wrote here is that the measure of angle A plus the measure of angle B is 180 degrees. Well, why is that true? Because of the definition of supplementary angles, right? So we're going to write definition of supplementary angles. So the reason why these two angles add up to give us 180 degrees is because by their definition, which is supplementary, they're equal to 180. Third statement. So from here on out, I am going to be substituting wherever I see A, 6x plus 105. Wherever I see B, 13x minus 20. If I add these up, they give me 180. So essentially, I'm substituting in whatever A is and whatever B is to set up an equation. So the reason why this statement looks the way it does is because of substitution. I substituted this expression for A, this expression for B. The next thing that I did here was I came up with 19x plus 85 is equal to 180. Well, how did I get that? I took 6x plus 13, I got 19x. 6x plus 13x, I got 19x. 105 minus 20, I got 85. So basically what I did here was I combined like terms. All right, and then the fifth statement is 19x is equal to 95. Well, I had to use the subtraction property of equality to subtract 85 from both sides. So here I'm going to write subtraction property of equality. And finally, once I did that and I ended up with this statement, I ended up with x equals 5. What did I do? Divided 19 on both sides, and I got 95. And I got 5. Okay, so I used the division property of equality. And the properties of equality, if you need to review this, are in lesson notes 1.3 or 1.4, either one of those, either 1.3 or 1.4. So you might have to backtrack and reread those notes to make sense of this. Okay, we're going to do another one together partially, but I want you guys to really think about how can I do this by myself, because you are going to have a try it out right after. All right, so we are given that line L and line M intersect to form 4 angles. 1, 2, 3, 4. We need to prove that angle 1 is congruent to angle 3. So basically what we're doing is we're proving vertical angles are congruent, basically, because these are vertical angles. So we're trying to prove that they are congruent. The first thing that we're given is this statement, and we're going to put a 1 here. Line L and line M intersect to form 4 angles. Why is that true, or what reason backs that up? It's given to us. What about the second statement? The measure of angle 1 plus the measure of angle 2, this angle plus this angle is equal to 180. What do you think? Well, linear pairs are supplementary. And I notice that we have that down here as well. Do you see another linear pair, another set of linear pairs? Yeah. Okay. So another set of linear pairs would be 2 and 3, right? 2 and 3. So we have 1 and 2, 2 and 3. Okay. So I'm going to write that the measure, or rather, measure of angle 180 degrees is equal to the measure of angle 2 plus the measure of angle 3. Linear pairs are supplementary. Here's where it might get tricky for you. So 4, it states that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. This speaks to that transitive property of equality. Why? Because if the measure of angle 1, if I add up these two, and I add up these two, they'll both give me 180 because they're both equal to 180 degrees. But this fifth reason states the subtraction property of equality. Well, in order to figure out what they mean by that, think about it this way. If I take the measure of angle 1 and I add it to the measure of angle 2, that's equal to the measure of angle 2 plus the measure of angle 3, because like we stated here, they're both going to give us 180 degrees, this side and this side. They're both a set of linear pairs. So I want to get this and this equal to each other. Well, I subtract the measure of angle 2 from the measure of angle 2, and I'm left with the measure of angle 1. So I set up an equation, which is equal to the measure of angle 3. And that's exactly what we're going to go here and put for number 5, is that the measure, if I isolate the measure of angle 1 and the measure of angle 3, they're going to be equal to each other. I'll put that here so you guys can make sense of that. And then finally, angle 1 is congruent to angle 3. Why? Because of the definition of congruent angles. Now, this is just a sample of the kind of proof that you may see, but keep in mind, proofs take a lot of time to write, and these reasons sometimes are not always the clearest, and as we work more on them, you will see how easy it gets, especially if you start thinking about a line of reasoning that is going to get you to your final proof, okay? You are going to try out this one, and if you notice here, you're basically completing an equation, and you're just going to be writing the properties of equality for your equation. So you might be using the substitution property, the division property, subtraction property, additive property. So keep that in mind as you're doing this, and also please take some time to look at lessons 1.3 or 1.4 to refresh your memory on the properties of equality. Okay? If you have any questions, please reach out or leave them in the comments box. Take care.